Chemistry students, in this video, you're going to learn how to calculate mass mole stoichiometry problems. In our last video, we were given moles and we had to figure out grams between one compound and another. But in mass mole stoichiometry problems, you're given the opposite. So in these kinds of problems, you are given grams of compound A, and you need to find moles of compound B. So once again, we are changing from one compound to another, and therefore we have to use a 6-window setup. All right. The other thing that I want to mention is that there's one little twist between solving mass mole problems that's a little bit different from solving mole mass, and that is the placement of the mole ratio. So if I draw a 6-window setup, like so, in order to solve our mass mole problems, we are still going to put our given in the upper left-hand window. We are still going to put our trying to find in the upper right, but the thing that's going to change is that instead of the mole ratio being here in the middle, we are going to put 1 mole equals the molar mass in the middle sections. And in our final section, this is where we will put our mole ratio. Now remember, the mole ratio has numbers that come from the balanced chemical equation. So the numbers are from the equation. And remember that with 1 mole equals the molar mass, I am calculating this for you, and I give you the molar mass of every compound in our equation, and I'm going to put in parentheses right below each formula. I give this to you. All right, so now that you know the basics, let's get started. Okay. So if we take a look at our equation that we have at the top, you'll see that I'm missing some coefficients. So let's fill those in for you. So in order to make this equation balanced, we need to add a coefficient of 3 in front of water and a 3 also in front of lithium hydroxide. So let's take a look at our very first problem. Oh yes, and notice, look, I gave you all the molar masses there, so don't forget that they're there. So I'm just kind of taking away that part of the work for you. Again, just to make sure that I'm testing that you understand how to solve the problem instead of testing you on how to calculate molar mass, which we've already done in a previous unit. Okay, so our question is, how many moles of ammonia, which is NH3, are formed if you start with 5.34 grams of Li3N, which is lithium nitride. So let's just first take a look and see what kind of problem we have. We are given 5.34 grams of lithium nitride. We are trying to find moles of ammonia, which is NH3. So this problem is grams of one compound to moles of a totally different compound. So since we're going gram to mole, this is going to be a 6-window setup. So we're going to do that right now. Here's our 6 windows. 6. Remember also, like, to write small, because there is a lot of writing in these problems. Okay, so as I mentioned, the given always goes in the upper left window, so that's what we're going to do. We're going to write 5.34 grams of lithium nitride there. And I said that our trying to find always goes in the upper right-hand window. So I'm going to write moles of NH3. Okay, so in our next step, we need to demote the units. So grams of Li3N is going to come down here. So we have grams of Li3N. So because we have to demote the unit, and because the unit is grams, this middle section can't possibly be the mole ratio like in the other problems we've been doing. This middle section has to be the molar mass because I've got grams at the bottom. Where do we find the molar mass? I calculated it for you. So find the molar mass of Li3N up here. It's right underneath the compound. And I have it as 34.83 grams. 34.83 grams of Li3N. On top, I have to put what it's equal to. That's equal to 1 mole. Remember I told you in the last video that if you have grams on the bottom, like we do here, you always have to have 1 mole on top. Likewise, if you ever have grams on top, you always have to have 1 mole on the bottom. They're equal to each other. Like, think of this as like a single fraction. All that we've done is we're taking a bunch of fractions and we're just welding them together to form these windows that we've been calling them. Okay, now this is 1 mole of Li3N. Now, because I have grams of Li3N at the top and at the bottom, I can cross out the G and the compound, and now I can move on to my next section. What do I write at the bottom of my next section? Remember, when in doubt, demote the unit. So I'm going to take moles of Li3N and rewrite it right here. And notice that it's underneath moles of NH3. This is where my mole ratio happens. And where do I get the numbers for the mole ratio? They're the coefficients that are found in the balanced equation in front of each compound. So what is the coefficient for Li3N? Well, look, I don't have anything there. So it's a 1, not a 0, a 1. What is my coefficient in front of NH3? Hey, nothing. I don't have anything there. It's a 1. So I'm going to put a 1 there. Now, in order to calculate this out, I have to multiply the numbers across the top together. So I get 5.34 times 1 times 1. And I'm going to divide that by the two numbers on the bottom multiplied with each other. 34.83 times 1. And when you punch all of that into your calculator, you should get 0.15 moles of NH3. Now, how did I know that my unit was moles of NH3? Because if I look back at my table, at my windows, I have moles of Li3N on the top and at the bottom, and what I'm left with is moles of NH3, and then that is how you always know what your units are. Now remember, if you want full credit, you have to have the number, you have to have the units, you have to say moles, and then you also have to tell me what the formula is for the compound that you're trying to find. All right, that is how you solve mass mole stoichiometry problems. But before we go, I just wanted to kind of clarify something for you really quickly. So I'm going to go back to my note sheet here. So we've learned how to solve a couple of different kinds of problems using the mole ratio. When you are given And then let's just put trying to find over here. When you are given moles of compound A and you are trying to find moles of compound B, this is a mole to mole problem. And this is a 4-window problem. And with those 4 windows, you put your given in the upper left, always. You put what you're trying to find in the upper right, always. And you need to remember that this section here is the mole ratio. And the numbers come from the coefficients in the balanced chemical equation. Now, that is a little bit different from the other 2 stoichiometry problems that we just learned how to do. So, if we are given moles of compound A and we want grams of compound B, now our units are different and our compounds are different. This is mole to gram or mole to mass, and this is a 6-window problem. And in my 6 windows, we are going to have our given and our trying to find, but now the mole ratio goes in the middle, and our molar mass goes at the end. The last kind of problem that we looked at, and I'm going to put it up here, is where we were given, let me use a different color, is where we were given grams of compound A, and we are trying to find moles of compound B. Once again, my units are different and my compounds are different. That's going to be, that's different, remember, from our 4-window problem because our units didn't change. It's mole to mole, even though our compounds did. But remember, if your units change and your compounds change, then you have to do a 6-window problem. So in this problem, this is grams to mole. This is a 6-window problem. And when I draw out my 6 windows, my given goes at the upper left. My trying to find is going to go in the upper right. But now, since I'm trying to find moles, this is my mole ratio at the end. And this is where my molar mass goes, in the middle. So if you are given grams, the molar mass goes in the middle. If you are given moles, then the mole ratio goes in the middle. So those are some things that you can try and remember. However, I can't say this enough. If you just remember to write your given in the upper left and to demote the unit, it will help you to see the pattern so that you can flow through it. If you're demoting the unit and the unit is moles, then you're putting the mole ratio in the middle. If you're demoting the unit and the unit is grams, then you're putting the molar mass in the middle. All right, everyone. I hope that that was helpful for you and good luck.